Yes. Well, I was going to say good afternoon, but it doesn't really make sense. So it's great to be here today. My name is David Potier. I'm a senior advisor with Indigo Ag.
My name is Ignacio Zuleta. I'm the head of remote sensing here at Indigo Agriculture.
We're both delighted to be here today to be a part of the conference. We were talking a little bit about this opportunity to have a video here for the conference, and the problem statement that Ignacio and I would like to talk about is the digital gap in agriculture.
Yes, where there's a lot of data that is not at our fingertips, and we wanted to discuss a little bit about how that data gap manifests itself and what's our perspective.
And so what we thought would be fun is, we're going to do three things together today then. We're going to talk a little bit about that gap. Let's all agree on what it looks like. We're pretty excited to be describing this data gap to everyone on this conference because we believe this group is a group that could actually change the gap for the better. We also want to describe a little bit about why it matters, why the gap is there, maybe speculate a little bit about why the gap is in place. And what we thought would be fun is show some examples with Indigo technology of what it looks like to cross the gap and to close the gap. So maybe a way to get started that I find energizing is just to take a look at a utility that we're all completely familiar with, which is Google Earth. Let's take a look at Champaign-Urbana. I bet you a lot of people involved with the conference today are hanging out in Champaign, and it's a place that a lot of us know well. It's a really cool place because it's a combination of an urban environment and a rural environment where a lot of corn and soy is grown. So it's a convenient place to come to. And if we go there in a place like Google Earth and hang out in Champaign, what we find is that the Google mapping environment does a great job of tracking the places that we all live and work and play in Champaign. It's remarkable. I mean, it's easy to forget how recent that is, right?
We've gotten so used to it, we think it has been around forever.
Right. But if you really do the math on it, it's really only in the last 20 years or so that we've had a pervasive digital model of cities like Champaign or even bigger cities like Chicago. The challenge is when you come outside of the city into this really, arguably one of the most important corn harvests in the world, it's really hard to find structured information. And one of the reasons is the imagery isn't consistent. So you can sort of see this color change is not because this farmer is doing something different on the left and the right. It's because we're looking at a patchwork quilt of imagery in the base map from different dates and different sensors, different stretches. And this is true in many rural areas. And then, of course, even if we had the imagery that was consistent, it's really hard. Try doing a search right now for corn. It's going to be hard to find unstructured data or find structured data about what's going on with the harvest.
We'll spend a lot of energy and effort inventorying, digitizing, and recording features and events in the places where people are.
Yes.
So we have very well-defined high-fidelity models and digital twins of cities, roads, places where infrastructure is, but not nearly as much information that is co-indexed in a way that it can be discoverable, navigatable, and it can be explored outside of cities. So the data might be there or not.
And you sort of wonder, well, what does it matter? And at Indigo, we think it matters a lot, and that we've taken on a lot of challenges as a company around how we market grain, how farmers are able to become more sustainable, and even become a part of the solution with climate change with our carbon program. And every one of those obstacles that we're trying to challenge requires reliable base map data and reliable digital representations of what's going on the ground. And so, we looked around at what was available at Indigo and realized, gosh, we were going to have to do some, we're doing some partnering, but a lot of build to really get this done. And, here's an example of what build looks like around here. And so this is a map of, the same part of Illinois, but we're lighting it up, thanks to Ignacio and the team, with, really high fidelity satellite signals that are available consistently for all the farms in the area around Champaign, and over time, which is critical, right? Able to actually watch those fields green up and brown down throughout the course of the year, so we have a useful characterization of what's going on farm.
Yep. And one of the things that powers this is going to be the availability of more and more heterogeneous sources of satellite imagery that will have to be incorporated, along with information about events in the ground that usually have sat in completely different realms of machine data, economic data, population data, a lot of information that needs to be put together to do, to support the decision making that will unblock the next generation of farmers managing their farms, right, for sustainability and new metrics and goals that we didn't manage for before.
Right. Really, the rules of the game are changing in agriculture, and we need a system that can keep up with them. And one of the assets, like Ignacio was saying, is understanding what's going on the ground. These little black polygons are all the farmer fields that are enrolled in Indigo programs all over the United States. And so those ground systems become kind of sentinel data. And there sure is a heck of a lot more satellite data coming in. I know you know a thing or two about that from your prior life.
Well, I spent a lot of years trying to make satellites work, build satellites, and designing satellites that could be used to monitor essentially agriculture globally, right? So, but the part that we're missing was the ability to have boots in the ground and partnerships to really join the information we have about the inputs to these processes with the outputs that we can see from space, so we can support actually active control of what happens on the farm.
Yeah, and that it's rare to find a company that's like Planet building new hardware in orbit and having that connection to the ground that you just talked about. When all the pieces come together, it's pretty remarkable. Here at Indigo, we used these digital traces from all of our customer fields and our research programs and the satellite feeds that we just talked about. We brought them together to build something pretty remarkable. One of the first, this is Champaign again, Champaign-Urbana, but now we have every farm in view. That's one of the things that's powerful about satellite imagery, is it's watching everywhere quietly and at reasonable cost for a lot of the sensors. And we were able to build a map not only of what's being grown, so we're looking at yellow is corn and green is soy, but also how these crops are being grown. And really, to Ignacio's point around making the connection to sustainability and making it easier, lower friction to make those claims. Here's the crop rotation history. Red areas are intensely rotated, which is really important for soil health and plant health. Here's tillage practices. These purple areas are not tilling. So these farmers are actually leaving the fields in cover season to season, which is excellent for retaining soil carbon between seasons. Here's the cover croppers. It's a lot rarer, this practice, but these red areas are fields that are keeping the field green all year round with cover cropping. And we can sort of put that story together and really build a view not only of individual farms, but of the whole region. And we're right in the middle, as I understand it, in your team of refreshing that study now.
Yeah, and these kind of studies are the ones that help us change also the culture of farming, because once we can identify farmers that are successfully deploying sustainable practices, we can connect them in space and actually start developing regional practices, so we can adapt what are good principles based on the science to what are good agricultural stewardship principles that incorporate not only agriculture, but how much water you use, how you treat your pastures, how do you manage the forests that surround your fields.
I love that idea. That pioneer idea is something that what really struck us, Ignacio, is these red cover cropping is one of the real tells on regenerative farming. It is rare in the country, right? It's only a few percent.
They are alone.
They're alone. They're these pioneers. But what's interesting is, there's almost no farm that's further than about 15, 20 miles from a pioneer. And so to your point around making connections and
yes, these are going to be the leaders. These are going to be the seeds of the change in how we farm. So it's super important for us to be able to map this globally and help us just drive change.
So this is one example that we just told of what it looks like to cross that digital gap around the rural-urban split when it comes to geospatial data. We've got a couple more stories up our sleeves, maybe one more that I think could be fun. We'll go back over to our Atlas technology. I'm going to turn off some layers, Ignacio. And what I thought might be fun is we can take a look at one of the big problem statements that Indigo is wrestling with outside of the carbon program is green marketing, really building that electronic connection system for buyers and sellers of grain. It's remarkable how much progress we can unlock by digitizing that. So if you're going to do that, if you're going to digitize the sellers and buyers of grain, it seems reasonable to know where all the buyers are.
Yep.
And so we can take a look at all the grain elevators in the country, and there are thousands that really matter. That's a remarkably poorly structured data set. But bringing it back to the conference around the digital gap, there's another element that's missing on the map of American farming, which is local grain elevators, the ones that farmers build on farm. Over the last 20, 30 years, farmers have invested in on-farm silos to store grain in order to allow them to participate in the markets more effectively. It's remarkable how much storage they've built. Essentially, an entire U.S. harvest can now be stored on farm, hundreds of millions of bushels of corn. And there's no map for those locations.
Yeah.
You can't Google it. You can't buy a database of those locations. Farmers tend to not register them, and is one of the problems that we had to help understand where grain inventories are. And so we turned to computer vision, and so we partnered to do this. But we essentially identified every grain bin in the United States, and you can imagine it's a pretty classic computer vision problem, identifying circular objects in high resolution imagery. Again, partnered to do this. Remarkably, we turned up a lot of septic tanks and swimming pools. Computer vision is not for the faint of heart, but by putting in place enough rules, we were able to really settle in on more than 600,000 local grain storage bins, and that's really critical for understanding damage events that can happen, and helping farmers and the government respond quickly to flooding 2 years ago. And then this summer, it was all about derecho. So we watched this windstorm sweep through the Midwest, and we were able to light up where that derecho damage was happening. This is the state of Iowa, using radar imagery. And I know you've had plenty of experience there. It's remarkable how much more effective this radar data was versus optical satellite.
Yeah, I'm bringing new data. This is what we're doing here is very powerful, right? We're unleashing the power of deep learning and computer vision on imagery, and then we're creating now events on the ground. It's a record of event and essentially geospatial transactions, so to speak. And we're combining this with actually observing physical events on the ground. And when you connect that with the information we have access to at Indigo related to logistics, transport, we can start building big economical models that allows us now to understand what's the economical impact of weather events on the availability of grains. And it helps farmers and the buyers to tell a good story about how is all of this grain originated. So it allows us to now decommoditize a lot of these crops and start adding way more value to farmers, right?
Yeah.
Because now they don't have to sell at the lowest possible price. They don't have to expect the worst weather. They don't have to expect the worst market conditions. So I think we believe this is a very powerful tool to actually drive the incentives that will essentially make farming more sustainable and will help us match the needs of the buyers and the farmers, which ultimately will lead in environmental advantages. We'll probably eat less and better based on a lot of this technology. So
you're certainly not going to get any argument from me. We'll be preaching to the choir. I think we both agree that, and I hope that you all see the potential power, the unlock of closing this data gap, and like you say, Ignacio, really transforming the food system for the better. If you believe that, if you're past that part of the story, then what would be reasonable is to ask, well, what will it take? Like, what will it take to actually close the gap? And I've been working on one side of this problem for a long time, Ignacio, on using whatever pixels I can get my hands on to try to translate them into useful insights. Here's a derecho map, but we can also lay out the damage estimates, for all the counties in Iowa, and really translate that into an impact for our customers. So we've been stuck with whatever pixels we'll get. I think you've been working on the supply side of the data and imagery side of the house, yeah?
Yeah, and I'm really excited to now be on the side of applying the output of that imagery and starting to connect what traits of all the inputs we've used from remote sensing are the ones that have the maximum predictive power to the processes that are going on the ground. So it's a very unique opportunity for me personally, which is to understand very well the data that is going into these algorithms, and then trying to build the data structures and the products that allows us to do wall-to-wall inference on relevant high-level variables that describe farming. And this
Yeah.
is something that we believe, it's acutely facilitated by computer vision and pattern recognition and the kind of technologies that we've been discussing in this conference. So we really want to invite you to, we hope we can inspire you to develop more algorithms, to participate in the competitions with us, to work with us to provide you training data sets, label data sets, anything we need as a community to start creating traceable models of what happens on the ground that are facilitated by, again, continental wall-to-wall machine learning driven inference.
Yeah. I mean, those things you talked about sound like the unlocks, right? I mean, we know that there's going to be a lot more. We're coming into a golden age when it comes to imagery availability. But we all know that more pixels isn't the only part of the problem to sort of break this. If you had to break it apart, what would be the big components? We're obviously getting way better coverage. That's pretty exciting to see. The temporal frequency, the spectral diversity, the new energy sources like radar. Transformative, right? Lots more imagery coming. But what are some of the other elements of the problem in your mind to help unlock sort of?
I think what we need to do is, my suspicion is what we need to do is really embrace a type of interpretation of the data that is driven by models. I think we have a lot of ad hoc, empirical, unbiased interpretation of the data where we're trying to map essentially measurements of different kinds straight into outcomes. And I think this is a big challenge because we face a situation where we have a lot of data, but the data is so stratified so that it's actually a data poor problem. So a lot of the issues we have is we're trying to do data mining type of machine learning where we assume there is a lot of data and we're trying to regress against that data to understand what's happening on the ground. But the deep and profound geospatial stratification of the data means that we're actually data poor in the classes of the scenarios we're trying to analyze.
Definitely guilty as charged. We've done a lot of, in my prior life at TELUS Labs and in some of the work we do here, data mining is a tempting approach, right? It gets you fast to an answer.
And it's great when you have a lot of data.
Right.
And when you have a lot of data that you haven't stratified, you will have an upper limit into the precision of the result you can get. And how do you bridge that? You bridge it by adding priors, understandings of the models that govern the change over time of whatever you're looking at. And in the case, it's going to be farms. So we need to build models. And the models allow you to simplify dramatically the data requirements. So what is the challenge here? The challenge here is to build a shared community-based family of models. The models that govern the economics, the geophysics, the chemistry, the weather. All these models reduce the amount of data that is needed dramatically. We need to parameterize the farm and then discuss how much data do we need to close those models. And then can we estimate those models continuously on a map, wall to wall. So it's a fantastic opportunity to combine the best of machine learning, data exploration with actual modeling and parameter estimation. And that's going to be the key, I think, for the next generation of insight on farming. So I'm particularly very excited to, have worked with you, David, and the rest of the team at Indigo to build, the community, help train the professionals that will participate in this effort, which might be an effort that might take us a decade. This is something big, and we're not the only ones in the industry, but I believe Indigo is going to be definitely a thought leader in the space.
Well, it's been a pleasure to get to speak with everybody today. Ignacio, this was a lot of fun.
Yeah, likewise.
And good luck to everybody in the competition, and great to speak with everyone today.
Yeah, thank you.